Welcome back, and let's solve the Leetcode problem. So the Leetcode problem is a number of ways to assign edge weight 1. That is said underwrite the tree with n nodes level from 1 to n rooted at the node 1. So we are given a tree which is under a tree, start from the level 1, and then the tree is represented in two-dimensional integer array. And edges of lunch is an n-1, where each edge of index represent 0 is a u and 1 is a v, indicate that there is an edge between nodes u and v. Initially, all the edges have a weight of 0. We have to assign each edge of weight either 1 or 2. The cost of a patch between two nodes, u and v, is the total weight of all the edges in the patch connecting them. So we have to select the one nodes, x and maximum depth, and then return the number of ways to assign the edge nodes. Edge weights in the path from nodes 1 to 8 such that the total cost is odd. Okay, so we will select all the weights values across the tree. So since our answer may be large, we have to do it with the modulo of 10 power 9 plus 7, and we have to ignore all the edge not in the path from node 1 to x. Okay, let's check the XML1. In XML1, we have given like the only I would say one edge with two nodes, so which is start with 1 and end with 2. Since we only have to assign the value of weight is either 1 or 2, so we assign this as a 1. So the distance between these two return as a 1. And then, yep. So we also have to choose a 1 because 1 is odd number and 2 is an even number. How about the XML2? So in XML2, we can assign like 1, 2 for weight, 1, 2 for weight. What if we choose all the maximum depth is 2? What the minimum depth is 2 is if we see as a breadth search, this is the depth level depth search. This is the depth level 0, 1, and 2. This is called the maximum depth of 2. With node 4 and 5 at the same depth, either nodes can be selected for processing. For instance, a path from node 1 to node 4 contain two edges, 3 and 4. We have to assign the weights 1, 2 or 2, 1. So if we assign the 1, 2, that is technically choosing the odd number. So how about we choose like 2 and 1? That's where make us to choose the odd number, and then we can return the output in here as a 2. I think this can be solved by using the approach called breadth search. Let's create the mod first so that we can easily populate the data across the problem. 7. And yep, that is the modulo value, and 10 power 9 plus 7. Let's do the count. I was wondering how the edge should be, maybe to the plus 1. So let's create the graph first. What I mean by graph is we want to make sure that all these graphs are interconnected. I would also use a two-dimensional array for the graph, and that would be integer and repeating count plus 1. And then we just return the -1 here first. So that will be edge in edges let's create like the variables according to given by the question. U 0 V 1 graph of U pen V graph of V append U. So okay, let's print about what I am doing exactly in here. Actually, I'm just creating the level of degree that we could get in here, all the possible will. If we check in here, in example 2, I was creating the edge like array like 2, 3, which is in here, and next is 1 in here, and 1, 4, 5 like this in here, and 3 and 3. So that's technically connecting the two graph each other. And another thing I want to do is I will use the data structure called preferred search by using the Q approach. So let's call that as a node and integer value, and parent integer value, and depth. Also the integer value with the empty initialization. So originally I will put the Q of the node v1, which is 1 in here, and parent is 0 because we don't have a parent initially, and then depth is 0. If we search the preference, this is the depth 0, this is the depth 1, 2, and 3, this is the depth 2. Alright, so we got the depth, and we can start with the looping through all the count. How should we do it? Maybe create the index 0 originally, and we will create another one called max depth. How much depth we have to go through the tree. So let's say that if index is less than the Q of count, we will iteration through all the array. So let's go get the current value of the Q of index, which is 0 originally, and then we will increment the index to 1. And at the end, what we want to do is we want to populate the max depth from here. How can we get the max depth? By getting the we have to check the difference between the max depth and current dot depth, so which is from here. And then we have populated the max depth, which is stated 0, but the index is already 1. And then we will have a next iteration loop across the graph in graph of current dot nodes, so which is the index, and we will point in through the index 1, which is 2 and 3. So we are pointing this 2 and 3 for the next node. Oh wait, let me check. Yep, that's correct. That's the reason why we have an empty array in here. And next node, and we will calculate if next is not equal to the current of parent. What I want to do is I will append to the queue by next, and current node will be the parent, and depth will be current dot depth plus 1. Okay. And I think for getting the edge reset, I think we have to calculate the power function. What I mean by power function is, since we only have a weight of value 1 and 2, so we need the base value and exponent, and we also need to populate with the mod value, just an integer, and we will return the total exponent value. So we want like what if let's check the constraint together. What if the depth is 0? Let's call like exponent is less than or equal to 0. We just return the 1. And y exponent is greater than 0. What I want to do, if I will check it is the odd number or even number. 1, we will need a one variable called var zero. Okay, start with 1 first, because at least we have 1 at first. Reset will be the reset multiplying by base and mod. If not, we will just update the base with the I need to make the base as a variable instead of a constant let, and base into mod. And I will divide the exponent with the 2 and just return the result. So in here I can simply call the power of 2 mass depth and -1 and mod. I believe that will be the O of n for the space and time complexity. Oh wait, I also need the exponent here. Alright, that's a bad thing about Swift. Everything we put the variable in here is a constant value and we are not allowed to change it. Alright, so I think that beat like 100% for both time and space complexity. And time complexity will be the O of n, since we only go through from difference of 0 to n of the tree. The same for the space complexity, because we don't use any spare memory aside from the given size of the edge. Alright, hope you guys enjoyed the video and hope you guys have a good day. Bye.